Hi, in this video I'm going to show you how we can visually evaluate a function's limit using graphs. Now, I'm going to go through a few examples, and in each we're going to identify the left and right-sided limits, the overall limit, as well as the function's value and its continuity type at a given x value. So let's jump right in. The first question asks us, what's the limit of the function as x approaches 3 from the left-hand side? Okay, so what we'll do, we'll find our function, we'll trace the function through from the left-hand side until x equals 3, and we'll see that the corresponding y value is 5. So the answer to that one is 5. Next question. What's the function's limit as x approaches 3 from the right-hand side? So in this case, we'll trace the function 3 from the right-hand side until x equals 3, and we'll see that the corresponding y value is also 5. So there you go. Now, what's the function's overall limit when x equals 3? Okay, well, the function has a limit, and the limit is defined. We know that because both the left side and right sided limits are both equal to each other. So therefore the function has a limit when x equals 3, and it's defined at y equals 5. Yeah? Fourth, what's the function's value when x equals 3? Here what we're looking for, on our x-axis, we're looking for a closed, coloured in, shaded circle. And we see one there, and we'll see that the corresponding y value is also 5. And finally, what's the continuity type of the function when x equals 3? Well, this function is continuous when x equals 3. We know that because both the function's limit and its value when x equals 3 are equal to each other. Therefore, there's no jumps in the function, there's no breaks, there's no jumps. Okay. So here we'll simply say function's continuous. In this example, we're asked, what's the limit of the function as x approaches -1 from the left-hand side? So again, we'll trace the function through from the left-hand side until x equals -1, and we'll see the corresponding y value is 1. What's the limit of the function as x approaches -1 from the right-hand side? So again, trace the function through from the right-hand side until x equals -1, and we'll see the corresponding y value is 1. What's the overall limit of the function as x approaches -1? Well, the limit is defined. We know it's defined because both the left and right sided limits are equal. It's defined at 1. What's the function's value when x equals -1? Remember, what we're looking for here is a shaded in circle at x equals -1. Here we've got a circle, but it's not shaded in. What that means is the function's value is undefined when x equals -1. So it's undefined. And finally, what's the continuity type of the function when x equals -1? Well, the function's not continuous, it's discontinuous. The reason we know that is because both the limit and the function aren't the same at that given x value. So here, the function is discontinuous when x equals -1. And the continuity type is actually called a point discontinuity. So point discontinuity, because there's no jumps, there isn't jumps in either value, so as the limit approaches left, you'll see the value is 1, and at that point, the function is not defined, and then it continues from 1 all the way out. Yeah? So hence why this is called a point discontinuity. In this example, we're asked, what's the limit of the function as x approaches 2 from the left-hand side? So, as we've been doing before, we're tracing through from the left-hand side until x equals 2, and we'll see the corresponding y value is minus 3. Again, what's the limit of the function as x approaches 2 from the right-hand side? Trace from the right-hand side until x equals 2, and we'll see the value is 4. What's the overall limit of the function as x equals 2? Well, there is no limit. The reason there's no limit is because both the left and right side of the limits aren't equal. Therefore, the limit doesn't exist. Right? It just doesn't exist. Yeah? Now, what's the function's value when x equals 2? Well, what we're looking for at x equals 2 is a closed circle. We've got a closed circle. The corresponding y value is 1. So the function's value doesn't have to be the function's limit. They can be different. And finally, what's the continuity type? Well, at x equals 2, the function is not continuous. We know that because both the limit's value and the function's value at x equals 2 aren't the same. So here we've got a discontinuity. And this type of discontinuity is called a jump discontinuity. It's a jump because as the function's coming in from the left-hand side to 2, it jumps up to positive 4 and it carries on with its life. So this one is called a jump discontinuity. Final example. What's the limit of the function as x approaches 0 from the left-hand side? We'll start from the left-hand side, we'll trace in, and we'll see that the function never actually reaches 0 from the left-hand side. I mean, there's 0, the function never crosses, never gets there. So what does that mean? Well, it looks like, from the information we're given, it looks like we're going all the way down towards a negative infinity. Yeah. What's the limit of the function as x approaches 0 from the right-hand side? Same drill. Coming from the right-hand side, and we'll see it never actually reaches 0. So where's it going? Up towards positive infinity. What's the function's limit when x equals 0? Well, by now we know that the left and right side of the limits aren't equal, and the limit isn't defined. Doesn't exist. Yeah. What's the function's value when x equals 0? I can't see any closed circles when x equals 0. Therefore, the value is undefined. And finally, what's the continuity type? Well, this type of continuity is called an infinite discontinuity. Yeah? An infinite discontinuity. In the next video, I'm going to show you how we can evaluate a function's limit using good old-fashioned algebra. So if you like this video, like and subscribe. If you have any comments or queries, leave a comment, and I'll see you on the next video. Bye.